Now.
Welcome, everyone, to April's Global Health Institute Tuesday webinar. We are really excited because tonight is a very special night. We get to hear flash talks from our Planetary Health Scholars. I won't talk too much because we want to get to their talks and pepper them with questions, which I'm sure you'll have. If you do have questions, remember to put them in the chat, and that'll be the easiest way for us to take a look at them and pass them along to our Planetary Health Scholars. This program, which is a relatively new program, is a joint collaboration with the Nelson Institute for Environmental Studies. So Global Health Institute and the Nelson Institute collaborating together. And I'll just say that planetary health is obvious to many of us who've been working in these areas of global environmental change as it affects human health. People realize that we can't have a healthy human population on a sick planet. And so this new terminology of planetary health has actually reappeared because the indigenous people have been talking about this for a very long time. So I'd say we've rediscovered planetary health. Just 7 years ago, it was launched to expand upon global health. And it's similar, very similar to One Health, healthy people, animals, and environments. And tries to just be an umbrella area and show the urgency of the problem that we need to take care of our planet to take our own health. And our scholars this year, we have 5 wonderful scholars that you're going to be hearing from. There are their pictures and their affiliations. And you can, this is the order of the talks. We'll first hear from Kieran, and then we'll hear from Saga, August, then Nick, and then our last presenter is Katie. So very important to recognize that the exciting program we have just didn't come out of thin air. We are so grateful to our planetary health philanthropists, Sarah and Dave Epstein, who put forward the funds to establish this program. And also we have a planetary health postdoc who just started last week, thanks to Sarah and David's kind contribution to this program. That postdoc, her name is Hain Kim, who will be working at the intersection of energy and health. So thank you, Sarah and David. Without you, we wouldn't have this program and we wouldn't be here tonight. So without further ado, I want to thank you for coming tonight. I'm going to stop sharing my screen for a minute as I remind you to, stop sharing screen, as I remind you to put your questions in the chat as we go to our first presenter. So let me just get Kieran, your presentation up here. Okay, so I'm going to be playing Kieran's presentation. It's a video talk, and then I'll stop, and then she'll be available for questions. And Anne or Kaylin, just holler if something's not going right, okay?
My name is Kieran, and today I'll be talking about my research on air pollution and environmental justice. Climate change and air pollution are major planetary health crises. Climate change is damaging to ecosystems and human health, while air pollution, especially fine particulate matter, or PM 2.5, is a major cause of death globally and in the United States. Climate change and air pollution both represent a double inequity, as the most vulnerable contribute the least, yet face the worst climate impacts and the highest air pollution exposure. Climate change mitigation, however, can reduce air pollution and poses a potential mechanism to achieve clean air and environmental justice goals. How I just described the inequities of climate change and air pollution are examples of distributive environmental injustices, where the distribution of the exposure to and negative health outcomes are not equal across different groups. But this is a limited view of what encompasses environmental justice. Another important component is procedural justice, which relates to the equitable and fair access to policymaking. This can include access to data and tools used to investigate inequalities and possible policy solutions. One focus of my research is to improve the reliability and access to air pollution data and tools. First, in our air pollution data toolbox are ground level monitors, which record pollution for a specific location. However, as you can see from the map, their network is not spatially continuous. And since these monitors are expensive to deploy, their coverage is not expected to increase. While low-cost monitor availability is increasing, their precision limits their use in regulatory and policy contexts. Satellite observations, in contrast, are spatially continuous. However, similar to monitors, they can only inform what the pollution was on a specific time and day. Additionally, this data can be hard to use and navigate. The last bin of available tools are air quality models, which can ask policy what-if questions and backtrack the sources of pollution. There are two kinds of air quality models. One are full complexity models, which are quite challenging to use and can even require months of supercomputing power. The second type of air quality model are reduced form models, which utilize simplified atmospheric chemistry to estimate PM 2.5 concentrations. While this simplified chemistry does not capture nonlinearities that lead to secondary PM 2.5 formation and they can have a limited spatial and temporal resolution, reduced form models are much more accessible as they don't require supercomputers, require less expertise, and have shorter run times, while still being able to capture the majority of public health impacts from premature mortality due to the exposure of PM 2.5. A through line of my research is evaluating the strengths and weaknesses of reduced form models, especially for policy and environmental justice-oriented research, as well as applying these models to different questions and trying to improve them and increase their accessibility. Currently, I am using the InMap model and working to improve its predictions of types or species of PM 2.5 pollution over urban areas. InMap was specifically created for environmental justice air pollution analysis, as its grid allows it to have higher spatial resolution over urban areas. This is where pollution is often higher and a majority of people of color in the United States live. However, as you can see from the bottom right map, which compares the other two, InMap is underestimating sulfate PM 2.5 concentrations over Houston, Texas. Applying a scaling factor determined from the satellite observations, we can improve InMap's predictions. This will make a source contribution analysis, asking where does the pollution come from, more accurate, which can in turn inform policy and other mitigation actions. The next phase of my research will be doing this for a number of cities with inequitably high burdens of air pollution through a partnership with the American Lung Association. I would like to thank my advisor, Dr. Tracy Holloway, other collaborators, and the funders of this research, especially the Planetary Health Scholars Program.
Great, Kieran, that was wonderful. Thank you very much. And I'm glad that you mentioned Dr. Tracy Holloway, because of course, as well as our Planetary Health Scholars, they bring their advisors with them into the program. So now just a couple minutes for questions. Let me ask you one question. What are the differences, the pros and cons between this model that you talk about, COBRA, and the other one, InMap, these reduced form models? Or can you, yeah, so let me ask you about that
Sure.
first.
Nick, who will be presenting later, also does some analysis on air pollution and energy system change. And so I wanted to talk a little bit about the differences between our two models. They're both reduced form models, so they're linear models. They only estimate changes in PM 2.5, but in that model was specifically developed for environmental justice applications, and it uses a variable grid, which allows it to zoom into the urban scale. So it looks at, has a higher spatial resolution over highly populated areas and a smaller spatial resolution in more rural, less populated areas.
Okay. And one last thing, you mentioned your partnership with the American Lung Association. Can you say more about that?
Yeah, so aspect of my research that I really like is that it is very policy relevant, and some aspects of it are stakeholder driven. So the partnership with the American Lung Association is a newly formed partnership, but is one of the ways that I try to conduct engaged scholarship, which works to get the results of my research outside of just academic conferences and journals, but working with different stakeholders. And so one expected outcome of this research is going to be a report for the American Lung Association, and another is a presentation to their coalition of medical practitioners. So working to get the research that we're doing on air pollution and health outside out in the public, so that it can be connected to policy solutions.
Great, thank you. All right. Well, let's move on to our next presentation from Saga, and I'm going to share my screen and let me know if there's any problem with this. So here we go.
Hello, I'm Satya Saga, PhD student at the Sound Forest Lab in the Department of Forest and Wildlife Ecology. My project, under the guidance of Professor Zuzana Burivalova, aims to understand the biodiversity conservation benefits under carbon finance projects such as REDD+ initiatives. Globally, we have mounting evidence showing ecological networks comprising well-managed protected areas, community-managed natural landscapes, and corridors are fundamental for conserving biodiversity, for human well-being, and to combat climate change. Meanwhile, revenues from carbon finance projects designed to mitigate climate change by protecting forests and reducing deforestation provides an exciting opportunity to simultaneously protect biodiversity. An excellent example for a carbon finance project is the decade-long protection of Gola Rainforest National Park, GRNP, in the Upper Guinea forest biome of Sierra Leone under Gola REDD+ initiative. This initiative has been successful in reducing deforestation within GRNP, with projects such as promoting shade-grown cocoa farms, produces made from non-timber forest products, and fishing for local consumption. The initiative has made a tremendous effort to improve the livelihoods of local communities. However, no study has explicitly documented its efficacy to conserve faunal community, particularly those targeted for bushmeat and wildlife trade. My goal, which was partly supported by Planetary Health Fellowship, was to study the efficacy of Gola REDD+ initiative in protecting faunal communities. As a comparative site, we chose Gola Forest National Park, GFNB, in Liberia. It is a contiguous forest that is also part of the transboundary peace park with our main study site, Gola Rainforest National Park in Sierra Leone. But without any Red Press initiative in place to financially support its management plans. During a 4-month field work from November 2021 to February 2022, I collected bioacoustics and environmental DNA data to study the biodiversity response of species to protected area management. By the end of 2023, our project aims to provide explicit evidence regarding the effectiveness of a carbon finance project to serve a twofold objective of conserving tropical forest biodiversity while sequestering carbon. Going forward, at my study site, this project will result in data that will be useful for informing management actions based on sound ecological evidence rather than unpopular belief. Having developed this project in close consultation with management bodies, both government and NGOs, I am confident that my project's output will be used at the site level to inform future management actions and also to promote similar carbon finance initiatives in the region. Thank you.
Great, great. And just like our last presentation's advisor is a superstar, your advisor is also, Susanna is a top researcher, one of the world's top sound ecologists. So let me just, for those of you who aren't so informed about nature-based solutions to climate change, can you just quickly explain RED Plus, that initiative?
Sorry, RED Plus initiative.
Yeah.
Yeah. So, this is the initiative where people use carbon credits, or in a way, plainly to explain, protecting a forest and helping the local communities in exchange and giving them, resources like either education or hospital, and giving them alternative livelihood methods in exchange for not doing deforestation or not hunting or not illegally logging the forest.
Okay, so the REDD, reduced emissions from deforestation and degradation. The plus is sort of the added community element.
Community
right?
element, yes.
Okay, let me ask you another question. And then I see someone with their hand up. Why do you think it's important for carbon finance initiative to also take an effort to protect faunal communities?
I mean, without faunal communities, these forests that are being protected for, protected for against climate change and also against deforestation will be nothing but just floral carbon farms. Essentially like empty forests. And we also have mounting evidence that without faunal communities, which basically is defaunation, the forest that we see right now would be completely different. The entire composition might change, and also it will significantly reduce the plants' ability to kind of adapt in the future climate change. So I think it's extremely important right now to not just think about forest conservation with respect to protecting trees, but also the entire faunal community within it.
Great, thanks. Dorte has a question.
Yes, out of real interest, you said that you collected different types of data, if I understood correctly, forest audio data and DNA samples.
Yes.
How are you going to analyze the audio data, and how are you going to combine the two type of data?
Thank you so much for the question. Yes, for soundscapes or the audio data, we are doing something called soundscape saturation, where in each site we are trying to see how much of the sound space is being filled by the species that are calling them. It's to be in a plain, saying that if we don't listen to a particular species, like a duiker calling at a particular frequency, we know that the duiker won't be present in that region. And eDNA data we have collected, I mean, this is the first time ever we are trying to compare and combine eDNA with bioacoustics. Not been really done. So we're still kind of brainstorming how to combine these two data sets. But it's, I can't really answer that right now how to combine them, but I think it's extremely important to combine because most of the species that doesn't give out acoustic or doesn't call or make a sound can be picked up by eDNA. And I think these are two complementary kind of methods that are extremely important to study the forest biodiversity. But one way to kind of combine them is to try and do some kind of a joint species distribution modeling, because through acoustic indices and by labeling the acoustic data, we can identify individual species, and also with eDNA, we'll get individual species through DNA. So yeah, we could potentially do a joint species distribution modeling. Yeah.
It sounds fascinating. Thank you.
Thank you so much. Yes.
Great, thank you. Okay, so our next presentation is from August, and he's working with James Krall, who's a new faculty member who's actually one of the leading figures in planetary health, who we stole from Harvard, and we're lucky enough to have him here. And so August, working with James Krall, is the next presentation that I'm going to share. And again, holler if anything doesn't look good.
Hi, everyone. My name is August Easton Calabria, and I'm a second-year graduate student in the Krall Lab of the Entomology Department here at UW. And I'm going to talk about some of the research I've been fortunate to do as a planetary health scholar this past year. My research makes use of recent advances in imaging and computing technology to study collective behavior of social and native pollinators like bumblebees. I want to better understand how they're responding to the many novel stressors that the Industrial Revolution, globalization, and now the computing revolution have created for them. This past year, I looked at how bumblebee colonies respond to temperature stress and pesticide exposure, particularly to neonicotinoids, or neonics for short. In order to do this, I built a tool that I fondly call the Bombus box, which takes videos of bees that are labeled with these little barcodes like you see in the upper left-hand corner. They're called Aruco tags, and we use them to track the position of the bees within the nest. And with this data, we can look at both individual and colony level responses to stress. I'm continuing to develop this tool with the intention of it being cheap and easily accessible to researchers who are interested, because how I see it, it'd be very helpful to collect a global data set of pollinator behavior, for example, of bumblebees across diverse species and climates, in order to better understand how their responses to stress differ around the world. And I want to briefly remind us of exactly how important pollinators are to human health. Approximately a third of global food crops were produced with the help of pollinators as of 2006. And our agricultural system's reliance on pollinators is increasing. Due to the climate crisis, we also have an added challenge of shifting to a more plant-rich diet, which should further increase our pollinator dependence globally. In light of this information, the recent findings of widespread insect declines, dubbed the insect apocalypse, are quite concerning and present huge health risks actually for humans globally, which this graph here documents in years of life lost per 1,000 people. What I want you to take away from this is that humans depend on pollinators to varying degrees across the globe for food production, and pollinators face different stressors globally as well. So the effect of pollinator decline on human health in the US may look very different than in other parts of the world. And it's important that we capture that variation as best as we can. So now I want to convince you that using tools like the Bombus box is a good way of doing that. Here we track colony behavior changing as it gets colder inside of the nest. And I'm pointing out the thermal probes that I use to measure the colony's brood temperature. With this tool, we can get very information-rich, resolute data to look at the sublethal effects of things like pesticides and temperature stress on a colony. So here we can see it's at 20 degrees Celsius now. We're looking at behavior even colder now. And we can collect a lot of this data. I was able to image 45 colonies this past spring. And with that data, I was able to show that exposure to field realistic levels of neonics impairs colony thermoregulation, which raises large concerns about the effects of neonics on colony growth and reproduction. And finally, with the support of the Planetary Health Scholarship, I was able to travel to Chiapas, Mexico, to meet a researcher out of Ecosur, Alejandra Martinez, who was interested in using these tools and is now using the Bombus box to study similar questions in bumblebees in Mexico. And with that, I want to thank the Planetary Health Institute for this opportunity, especially Jonathan and Valerie, and as well as Sarah and Dave for their interest in this research and their financial support. And finally, I want to thank my co-authors, Maddie, James, Matt, and Brett, without whom this research would certainly not have been possible. Many thanks again.
Great, thank you, August.
Yeah, of course. Thanks for watching.
So let me ask you a question, then I see, oh, there's someone else, that's your advisor clapping, not a question. So what kind of contributions to crop pollination do honeybees make versus bumblebees or other wild bees?
Yeah, that's a good question. You might have noticed that I didn't mention honeybees at all in this lecture. And we do rely heavily on honeybee pollination, like for example, here in the United States, but globally as well. I think the issue is that honeybees are not native in most parts of the world that they're used as pollinators. They're more of like a crop, kind of like a domestic animal, basically a farm animal. And there are concerns that one, that they're actually out competing, because if we take for granted that insects generally are having a hard time right now, and then we look at honeybees and we can create these massive colonies of like 60,000 workers to a single hive, that we're actually helping them out compete native bees in the area. And so there's been kind of a shift recently towards looking at native pollinator health, especially as honeybees with colony collapse disorder. I don't know if people are familiar with that, but honeybees themselves are not doing so well right now. So we're starting to question our sole reliance on honeybees as our pollinating animal, and that we should be looking at ways to foster a greater diversity of native wild pollinators to do some of that work as well. So does that answer your question? Cool.
Yeah. Sarah, are there any other questions? Clarence, were you signaling, raising your hand? No.
All good.
Okay. Great. All right. So our next speaker, let me share the screen here. Our next speaker is Nick Mayu, and he is working on air pollution, similar to Kieran. And his advisor is so lucky to be working with him because he's an amazing student. I am his advisor. So here's Nick's presentation.
Hi, everyone, and thanks for being here today. My name is Nick Mayu, and I'm a PhD student in the Environment and Resources program in the Nelson Institute. And I'm going to be talking today about some work I've undertaken with UW alumnus David Abel and professors Tracy Holloway and Jonathan Patz. So this work is entitled National and Regional PM 2.5 related air quality health benefits from the removal of energy-related emissions in the United States. First, some background. The current energy system in the United States is dominated by fossil fuels, which, in addition to contributing to global warming and associated climate change impacts through the emission of greenhouse gases, also emit criteria air pollutants such as fine particulate matter, or PM 2.5, sulfur dioxide, and nitrogen oxides that are damaging to human health. Exposure to ambient PM 2.5 leads to hundreds of thousands of deaths each year in the United States. This means that by shifting energy production and use for electricity generation, transportation, and in buildings and industry, away from fossil fuels and toward cleaner sources can have profound human health benefits in the near term while helping to mitigate climate change in the longer term. We had two main goals for this study. First was to quantify the air quality health benefits resulting from the removal of energy-related PM 2.5 emissions in the United States. Second was to determine the regional distribution of health benefits from national and regional emissions removal. We know that emissions released in one place can have harmful effects downwind, and our work attempts to clarify how much of the benefit from emissions reductions occur in the region where emissions were removed and how much flows to other regions of the country. To accomplish this, we used COBRA, the Co-Benefits Risk Assessment Screening Tool, a reduced complexity air quality model and health impact model developed by the US EPA. COBRA estimates county level changes in ambient PM 2.5 concentrations resulting from changes in emissions of primary PM 2.5, sulfur dioxide, nitrogen oxides, ammonia, and volatile organic compounds. We analyzed the health effects of the removal of emissions from 6 energy-related sectors. For each model run, we reduced by 100% or zero out emissions from the relevant sector or sectors. We model nationwide emissions removal from all 6 of these sectors simultaneously. We also model nationwide emissions removal from each sector independently, as well as statewide emissions removal from all sectors simultaneously, which we then aggregate up to the EPA region level when analyzing the regional flow of health benefits. So digging into some results here. This map is showing the decrease in ambient PM 2.5 concentration that would result from the simultaneous removal of emissions nationwide from all 6 sectors. So we find a nationwide population-weighted baseline PM 2.5 exposure of 7.41 micrograms per meter cubed. This decreases to 5.52 micrograms per meter cubed, assuming simultaneous emissions removal from all sectors. So some interesting patterns are evident in this figure. We see large county level PM 2.5 reductions around the Ohio River Valley, where large amounts of coal are still used for electricity generation. Natural gas and heating oil are more common sources of home heating in the Midwest and Northeast than in other regions. We can see the coast of Texas and Louisiana, where there is a large oil and gas refining sector, and the effect of vehicle emissions are evident in California. Because of these changes resulting from the removal of energy-related emissions, we estimate that 53,200 premature deaths could be avoided each year across the country. This decrease in mortality and reductions in illnesses related to PM exposure together provides $608 billion in monetized health benefits each year, almost all of which is from avoided mortality. The greatest portion of these benefits comes from emissions removal of highway vehicles, followed by residential and commercial fuel use, and then electricity fuel use. Now on to regional benefits. Assuming independent emissions removal by states in each EPA region, we find that an average of 69% of benefits, which we represent by our avoided mortality totals, 69% remain in the region where the removal occurred. This ranges from 32% in the mountain region, which we can see 8th down on the left, and on the other extreme, 95% of the benefit of emissions removal in the Southwest, which includes California, stays in that region. Even though just 32% of the benefits in the mountain region remain there, this still translates to close to 600 avoided deaths each year in the region. On the other extreme is the Midwest, which would prevent about 8,500 deaths within the region from its own emissions removal efforts each year. We can also compare the benefit a region would receive from its own actions to eliminate emissions compared to that it would to what it would receive from national action. So that's shown in the figure here. So you can see, looking at the Great Plains region, that it would get more than twice as much benefit from national action as from regional action, whereas the Southwest gets just 7% more benefit from national action. So we get those ratios by comparing the relative height of the dark blue bars, which is the portion of benefit that a region retains from its own emissions removal, compared to the light blue bar, which is the amount of benefit that a region would receive from nationwide efforts to reduce emissions. And then the gray bar represents the additional benefit that emissions removal in one region passes on to all other 9 regions. Overall, we find that the removal of energy-related emissions in the United States would lead to substantial health benefits from improved air quality. These results offer a clear rationale for mitigating climate change on public health grounds, showing that the sooner the US acts to reduce emissions, the more preventable death and disease from energy-related air pollution can be avoided. Thanks so much for your time.
Hey, thank you, Nick. That was wonderful. So, quick question. Were there any surprising results from this work after you finished the analysis? Any
Thanks,
surprises?
Jonathan. So one thing that I briefly mentioned was the breakdown of which sectors result in the greatest avoided mortality totals. And we find that electricity fuel use is not number one, which really is a good news story, because it's a lot of past research, whether 5-10 years ago, which probably show electricity as the greatest contributor to PM mortality. But because there have been such strides toward decarbonizing electricity relative to other sectors, and the transition from coal to natural gas, and to an extent to renewables like solar and wind, there's already been a lot of benefit realized by emissions reductions in that sector. And really across all the sectors we model here, because of the data we're using, which is from 2014 to 2016, thereabouts, emissions of all the pollutant types we looked at, and in almost all the sectors we looked at, have continued to decline since then. So really, when I talk about that 50,000 avoided deaths, we have already realized some of that benefit, which is showing that we are on the right trajectory, if not as fast as we might want or need to be.
Great. I see a question from Dr. Kroll. James.
I've got a very simple question. What is happening in Florida? It seemed like you had all the other areas highlighted, but is that just population density? Or?
It's just population. Yeah. I mean, I make the joke that sometimes you do this kind of work, and especially, well, that one is showing ambient concentration change, but if you're showing like a map of health benefits, a lot of times you're just reproducing a population map, because there's so many people exposed in Cook County and LA County and Miami-Dade that those places always tend to stand out. And any city showing up on a map like that is probably going to be due to transportation emissions as well, since they're just so much more localized than the things like electricity generation.
Great. All right, well, let's go to our last presentation from Katie. And I'm going to share my screen. Katie is also working with another superstar faculty member, Dorte Dulfer, an expert in infectious disease modeling. So here comes Katie's presentation.
Hello, everyone. My name is Katie Tradnik, and I am a Doctor of Veterinary Medicine, Master of Public Health candidate. And my project is on livestock biosecurity and zoonotic disease, and lessons that I've learned from Uganda and how I hope to apply those to next steps in Fitchburg. So with nearly 60% of the Ugandan population under the age of 20 and 2/3 of the population experiencing moderate or severe food insecurity, projections show that the demand for animal products in Uganda will increase exponentially over the next 3 decades. Given that the transformation of the livestock sector is expected to take place in the near future, I was interested in the perceptions of biosecurity and zoonoses among the smallholder farmers in Uganda, which make up about 92% of the population who own livestock. To study these relationships, I collaborated with Dr. Curtis Youngs of Iowa State University's Center for Sustainable Rural Livelihoods, which is located in the Kamuli district of Uganda. So we hoped to develop a survey, and we did develop a survey that looked at animal management, disease transmission, biosecurity, and animal and human health. We then were going to hire Ugandans to administer the survey, people that were more familiar with the community, and have a goal of about 150 respondents. I then was going to analyze the survey data in the US and use the data to identify community needs. And I was going to conduct focus groups with the people that administered the survey to reduce the bias that I had on the survey results and clarify any connections that needed some clarity. The next step would be for me to travel to Uganda for 6 weeks and work with the community to use identified needs to build a health promoting initiative based on the survey data and based on working with the community. Ultimately, though, after a year of waiting for research approval from Uganda, this is as far as we have come. Unfortunately, I had to let the Uganda project go because I'm running out of time to complete my MPH capstone project. But while a little piece of me feels as though I have failed, I am assured by many others that my experience is certainly not a rare one. And I did learn a lot from the experience that I had. I learned how to construct a survey that will be used for this research purpose in the future once it gets approved by Uganda. I learned how to collaborate online with folks that I've never actually met in person, both because of COVID and because of distance. But most importantly, I learned about relationships. So I certainly learned that you can build relationships virtually with me in Madison, Wisconsin, and Dr. Youngs in Ames, Iowa. And I chose to work with Dr. Youngs in the Center for Sustainable Rural Livelihoods because they have an established connection with the community in Kamuli District, Uganda. And I thought that working with this project for a year, I too would have such a connection with the community. But unfortunately, because of research approval delays, likely some COVID things, and other unforeseen influencing factors, I don't have a relationship with this community, which, reflecting back on, I definitely was getting some white saviorism vibes, which is an ideology that white folks uplift marginalized communities when in fact, perhaps they did not need to be uplifted. And it stems, I think, from white folks not building relationships with this community before doing research with them. And this is definitely not a narrative that I wanted to perpetuate in my work. So it made me do a hard look at global health in general and the MPH capstone project in particular, in what we're expected to do in such a short amount of time. So this summer, I still need to finish an MPH capstone project, but I'm going to do it locally. I'm going to do it in my home city of Fitchburg, Wisconsin, with the community that I know pretty well, and I know their needs, and I know the community organizers. And I hope that this was easier to do on a global scale, and I really encourage you to think on how we could facilitate community building and relationship building among researchers and communities, and how this could impact global health research in the future.
Great. Thank you, Katie. And this is something that happens a lot where your database falls through and you have to be flexible and shift gears. So that's a big learning experience as well. So quick question. You stated that you have to complete your project this summer. You mentioned you started to talk about your ideas in Fitchburg. So what are some of these that you're pursuing?
Yeah, absolutely. Thank you, Jonathan. I also want to acknowledge the fact that I didn't put an acknowledgement slide in my presentation, but I am thankful, certainly, for Dr. Dope for his help and Jonathan's help and Valerie, and certainly for the Epsteins for their contribution as well. But about the project in Fitchburg, so I'm still in the phase of reaching out to folks, and I have a good relationship with two of the alder persons on the Common Council of the city of Fitchburg. And there is a teen center that is in the planning phases for my neighborhood, which is a lower income priority neighborhood within the city of Fitchburg. So that is one possibility that I could work with those folks. There's also a pay-as-you-can restaurant that hasn't fully come into fruition yet, called Little John's. That's also in my neighborhood. So it's essentially, the model is, if you can't pay, then you don't pay. So it's trying to eliminate food security, but then if you can pay, typically people that can pay for their meal pay more. So that's kind of eliminating the cost that people that can't pay, like, kind of, I think you understand what I'm trying to get at. And then we also have the WVDL in the backyard. I'm at the vet school right now, which is the Wisconsin Veterinary Diagnostic Lab. And one of my other faculty advisors is Dr. Keith Polson. And I'm not sure if you've heard, but there's a highly pathogenic avian influenza outbreak right now, which is very pertinent to animal health and public health. So that's another pathway I could go down. I've also started building relationships with folks at WisCares. That's a lower income community care clinic, veterinary clinic, that's in Madison, and trying to work with them potentially for a project there. And lastly, there's I'm not sure what the proper term for it is, but it's called Grasslands 2.0, and it's an initiative that's UW based, and it's essentially trying to increase the amount of grazing land and grazing ruminants on the land, kind of in a regenerative agriculture ideology, and how that can be used as a climate solution. So there's certainly lots of opportunities, and I'm hoping that one of them sticks.
Great, thank you. So we have about, yes, thank you, everybody. Thanks all 5 of our scholars. And we've got, in the 11 minutes remaining, we have time for Q&A, and I see a lot of very smart people on this Zoom. I see 2 of our board members. I see past Planetary Health Scholars. I see supporters of the Institute who have been to more global health programs than anyone on campus or maybe on the planet. I see Jack and Sandy Winder there. So anyway, so this is open, and you scholars, you can ask each other, if you want to stump your colleague too, throw them a curveball or something. So open for questions. You can either raise your hand or just put your question in the chat. I'm looking. Okay. All right, James is going to ask a question while the rest of you figure out your other questions. Go for it, James. Okay.
Questions for Satya, and I was just thinking a little bit about what you were saying about these interesting sort of goals of both conserving biodiversity, sequestering carbon, but that also there's a sort of human nutritional component in there of bushmeat or other sort of vertebrate consumption. So I don't know, are you looking at how much of I guess my question is what are the sort of regulations in these areas on bushmeat consumption? And I know there's the regulation and there's the practice. Is that an intersection you're looking at or thinking about at all? It just seems like in the human health and nutrition context, it's actually a super interesting intersection.
Yes. Thank you, Kyle, for the question. But yes, there is a bit of difference. Okay, first of all, I'm trying to use a quasi-experimental design kind of a thing by the treatment being the GRNP area where the Red Plus project is, and the control side is on the Liberian side, which is the contiguous forest. but the only thing that separates them is a small river. But people move around and animals move, and in both of these protected areas, there are rules and regulations that you cannot hunt. There is no bushmeat. Bushmeat trade in all of these regions is illegal, and you cannot legally sell bushmeat even in the open. And this was, after the Ebola epidemic that happened in that region, which these regions were a hotspot and a lot of people lost their lives. There has been a lot of push to reduce bushmeat trade, but as you said, regulations is one thing and practice one thing. Yes. So what I'm trying to see is that whether having like the splits, as they say, yes, we are reducing the deforestation and forest degradation, but having the press and giving them other alternative livelihood mechanisms and asking them not to hunt and giving them other opportunities to have better livelihoods could potentially reduce kind of the next epidemic in that region, and which I think is extremely important because they just came out of Ebola and they're already in COVID-19, and I hope that doesn't happen in the future. But at the same time, I think yes, that is one side, but also this place has always been like a hotspot for wildlife trade. The next country is Ivory Coast. It was named Ivory Coast because of the trade of ivory that was happening there, and most of these places have lost their megafauna. So I think there's so much potential to save fauna diversity in that region, but at the same time having a healthier planet. Yeah.
Thank you, Sagra. Dorte, I have a couple questions in the chat. If you could just let me ask these questions, and then I'll come back to you. So August, this comes from a world leading authority in infectious diseases. So and ecology, Mary Wilson.
I'm ready.
Okay, this is a member of our board, Dr. Mary Wilson, internationally renowned. And her question to you is, do different species of pollinators compete within territories? Do they have distinct territories, or do multiple species of pollinators co-inhabit the same geographic area? And after you answer that question, a quick question from Valerie Peterson, tell us about getting those chips on the bees.
Yeah, no, that is a very good question. So yeah, pollinators, and I study bees generally, so I'm going to talk about bees, but they evolved with flowers, right? So different pollinators have actually specialized to certain extents on different flowers, that the morphology of the flower actually coincides with kind of the way that the bee is shaped in a certain way. And so there are certain flowers that some bees like a lot and others that they don't touch too much. So you do have different species that co-inhabit and may not be competing because they're feeding on different flowers. But there are also species like bumblebees and honeybees that are more of generalists, so that will go to many different flowers. So it's a complicated question, and I'm not sure it's something that we're actually in the lab looking at right now, like competition between different species. But yeah, I think I'm trying to think of one of the reasons why we're focusing on native pollinators is because honeybees are not evolved to a lot of the native flowers in this area. They're not always that good at pollinating them. So you can actually get a higher return almost from pollination input from native pollinators that are pollinating flowers that honeybees don't pollinate quite as well. I hope that answered your question. It's still, I think there are aspects of it that are still open for research. And to Valerie's point, it's actually this special kind of paper that is waterproof and very durable, and we actually glue them onto the thoraxes of the bees, which is not the nicest thing to do, and I feel badly about it, but we do it all the same. So they don't seem too disturbed by it once the glue dries and everything. So
I was going to ask you how you coax those bees into slipping into that little knapsack, wearing that little knapsack on their back. But,
oh yeah. No, we place it on them after we either cool them down to get them to lower, a little sleepy, or we use CO2 for the same effect. But just briefly, get them into a low energy state and put it on, and then they wake right back up again. So
great. She says, thank you for your terrific presentation.
Oh yeah, I saw that. Yeah,
okay,
no problem.
Dorte, did you have a question?
Yeah, for August again, I found it so interesting to have the bumblebees in your bumbles box, the bumble box. Could you imagine doing this tracking of the bees on a larger territory, or is this impossible? Like if you had them in a netted area or in a fenced area, bumblebee fence.
Yeah, that's a good question. It's also something that we've been exploring. Yeah, so we've actually done that. We use these security cameras, and we have these little hoop houses that kind of like greenhouses where we can contain a bunch of plants, and we will let a colony out inside of these hoop houses, and we put these security cameras pointed at actual flowers, and so we'll get recordings of actual pollination events. And so that way we can actually integrate both the within nest behavior, because there are these whole types of behaviors that are happening inside the nest, right? And then these pollination behaviors that are occurring when bees are leaving the nest to forage. Yeah.
So with 2 minutes to go here, I just, August, I knew that your presentation would start a buzz, but yeah, you've heard that before. So I have a question for Kieran and for Nick together, because your presentations are on air pollution and opportunities to have health benefits if we get off of dirty energy. If you had the microphone and President Biden and his administration was in front of you, based on your research, what would you tell them if you had a 6th-floor elevator ride with the president, and then he'll talk to his staff as well? Kieran, how about you? What would you say based on your work? What should they know about?
I think that they should know that there are massive public health opportunities associated with decarbonization, and the sooner that we decarbonize electricity and transportation, the more lives we can save, the fewer asthma attacks there will be. And then there's also a potential for these types of policies, depending on how they are implemented, to alleviate some of the racial disparities in air pollution exposure and health outcomes from air pollution. So being intentional with climate policies can also achieve air pollution goals and equity goals, as well as help address the climate crisis.
Right, great. And Nick, you were the same elevator, so you know that your work is related. What is your different take for President Biden?
Yeah, she wrote it up, and she talked on the way up, I talked on the way down.
Yeah.
I need to be delicate because, I mean, the Biden administration has been doing a lot, and they've been pushing their Build Back Better agenda. And it's the unfortunate reality that it seems we can't get Senators Manchin and Sinema on board to pass what would be the most consequential federal climate action in United States history. So I think acknowledging that reality, I would probably suggest that he do everything within his power through executive action. That includes not taking, like undoing steps he's already done, like expanding oil and gas leasing on federal lands, which is an unfortunate decision that he's made when he ran and won, inspiring young people that he was going to be the climate president. And if he wants his party to maintain control in the midterms, he's got to live up to some of those promises.
Okay, well, I'm sure that your research will be very informative to any policymaker. Both of you, this, energy is so critical right now. So, well, it is past the witching hour, so I want to wrap up and say thank you to all the presenters and to their advisors and to the sponsors of the program, to Dave and Sarah Epstein, and to all of you who have come out to be the audience of the very important audience for this Planetary Health Scholars Flash Talks evening of excitement. So with that, thank you for coming to this, and all of the scholars and their advisors who are available. We'll meet in an hour for our banquet, final year banquet for the Planetary Health Scholars Program at Steenbach. We'll see you at 7 p.m. Dress is informal. That's what I'm wearing, right? So anyway, thank you, everyone, and have a good evening.
Yeah, thank you all for listening.
Take care.
Thank you, everyone.
Thank you all.